Okay, so we have a certain crypto code must contain one letter from the first set and then three distinct letters from the second set. And then since there are X and Z in both sets, these letters may appear twice in each arrangement. So how many crypto codes are possible? Like, okay, so let's go ahead and write those sets. So I'm gonna call this a set like 1. So that has the X, K, M, and Z. And the set 2, okay, so we have another set. Let's say this is set 2. So I have W, the X, Y, and Z. So like since we have something common, so I just like to kind of do color coding. So we can get X from the first set or from the second set or from both. So which is what I'm gonna organize the approach like counting. So if I choose X from the first, okay, so I have like a couple options for the second option, like the choice from the second set. If I choose X from the first set, then I can choose X and Z, which is the bad guy from the second set. So if I choose both, then I already have three letters. I need one more from the second set. So let's say we are gonna choose W or Y, we can just choose one of them. But I'm gonna just highlight this one because whatever I get from this arrangement, I will double that because I can swap W with Y, which is why I don't want to rewrite one more time. This is one thing we can do, but this is not the only one, right? We can actually choose the X from the first set. Maybe we can do a couple more as well. And since we chose X and Z from the second set, there's like only 4, which is like if I just do 4, choose 3, which is 4 ways to achieve that. But since we are gonna have like 3 of those, there is at most 4 ways, but I just did 3, so we will see if we need one more. So instead of choosing X and Z from the second set, so let's say we are gonna choose X but not Z, then that will force us to get W and Y from the second set. Instead of choosing X, we can just choose Z, and that will force us to choose W and Y from the second set as well. But if I don't choose X or Z from the second set, then I have only 2 left, so which is why I cannot do anything other than these 3 approaches. So these are the only ways I can choose 1 from the first set and 3 from the second set if my X must be in the from the first set. So, but we can do the same thing with Z, right? So if I choose Z from the first set, we have the same scenario going on. So I can choose like X, Z, and W from the second set, and then X, W, Y from the second set, or Z, W, Y from the second set. And then if you look at these 6 different arrangements, if you double these, there's like 2 more. And there is no really common like pairs, common, I guess, for letters. So which is why we are safe. So we have to check those as well. But this is this is covering the bad guys, which is X and Z. So what we want to do also, the K and M. So if I choose K from the first set or M, so I have 2. Maybe I should do this one and double that number because there's no difference between that in terms of counting. So I need to choose 3 other from the second set, which as you see, K is not in the second set, which is why it doesn't really matter what 3 you choose. If I choose, I need 3, so that's gonna be done for choose 3 ways. That will be 4 ways I can choose any 3 letters. Like, let's say one of those, like example, I can go with like K, W, X, Y. So if these are the 4 letters I have to arrange, that might be done 4 factorial ways, which is 24. And then this is not different, so I need to like combine M with any 3 letters, which is also can be done for choose 3 ways. And that will be also 24. Again, this was an example, so you can change those 3 from those 4 anyways. So we have 24 ways to achieve this, 24 ways to this one, but let's think about the other ones as well. So like, make sure this could be changed like with Y, so we can swap those. since there are 4 letters, and then if 2 of them are equal to each other, so we can achieve this 4 factorial divided by 2 factorial ways to arrange them, which is going to be 12. But again, since we are going to swap this with y, that will be twice as much, which is going to be just 24 for this case. Okay, so we have 24 on this case, and then there is no difference. So this is also 24. And the second one, again, these are the only 3 ones. There is no swapping as we did here. So this is going to be done just 4 factorial divided by 2 factorial because of these 2 repetition. So this one will be just 12 phase, 4 factorial divided by 2 factorial. And then this is also 12 phase. And this is also 12 phase. And this is also 12 phase. So like if you combine these two, that's 24. Combine these to 24. So we have 1, 2, 3, 4, 5. This is 6. There is 624, right? So let me double check. But here's a problem with that. Okay, so we have to be careful. So like I said, there are 24 ways to achieve this, right? But they're like these 4 letters that we choose, any 3, that was 24, but we can choose those 3 letters 4 different ways, which is why we should actually multiply these by 4 as well. So which is why I don't rush through. So now we have 124, 224, 3, 4, and then another 4, that's 1224. So 12 times 24. Again, this is 12 times 12 times 2, which is 288. So there might be some other ways, but I think this is not too bad. So I hope that was clear. I'll see you in the next video.